that service company server has been polling, then goes and asks the rig server if it has any new data, and the rig server asks the LWD contractor if it has any new data. You know, that all waiting for all of those queries to finish can mean the data is 30 seconds, a minute, 3 minutes, you know, a few minutes old. And what Thomas will talk about when he talks about Statoil's use case, what the operator community wants is instantaneous transfer of the data from the field to the office. So we want to use our bandwidth for moving data, not for asking if there's any new data, and we want the data to be as fresh as it possibly can be. There are other requirements. We wanted, the internet has sort of come along since WITSML was invented, and we wanted to use internet technologies because that increases the likelihood that an operator will be able to deploy a real-time data solution if it uses the same ports and all the same infrastructure that companies are already having open so that their employees can have access to the internet. And finally, we didn't want to create something that people would have barriers to licensing for. And the business basically said they wanted all of this stuff now. So this is the original use cases, and really the community came up with a lot of use cases, but the ones that we described earlier are the most important ones. I want to imagine that I have a sensor streaming data to a consumer of data, or maybe I have an aggregating server that wants to bring data from one server to another, which is kind of a synchronization. People want to have the capability to subscribe to data. Subscribing in this sense means that maybe there's a piece of data that's going to appear in a rig site computer that isn't there yet, so I can't ask for it. But I can tell with ETP that if any new data appears associated with this well or this directional survey or whatever it is, if any new data appears that I haven't asked for, please let me know about the existence of that data, and then if I want it, I'll tell you to send it to me. But at the end of the day, what people said was that they don't care whether it's a pigeon with a jetpack. All they want is their data, and they want it now, and so this is the fabled pigeon with a jetpack. So these are the protocols that are in ETP, and I said before that a protocol is just a collection of messages. The messages aren't very complicated from an IT perspective, and they're really pretty simple to understand. So the first two protocols, core and channel streaming, are the ones that relate to real-time data. The protocols after that are the part of ETP which functions as a replacement for the programming interface in WITSML and ProtoML. RescueML never really had a programming interface. So now ETP functions as the new programming interface for all three of our flagship standards, and also a replacement for the real-time aspect of it. And here's what's in these individual protocols. So in Protocol 0, as a developer, if I'm writing an application that's going to consume data, whether that's a technical computing application or if it's a server I'm trying to synchronize or whatever it is, I talk to what looks to me like a sensor, and I say, am I allowed to talk to you? And it authenticates me and says, yes, you are. I ask it what it's capable of doing. Does it support compression and encryption, and does it support WITSML 2.0 or whatever? And then it tells me what it supports, and if I'm happy with what it supports, and maybe it tells me it supports encryption and not compression, if I'm happy with that, then I ask it if I can have a session, and it gives me a name that we're going to use for that session, a permanent name. We need a permanent name in case the connection gets dropped and I reconnect. I want to be able to reconnect to the same session. And that's all there is to it. It sends me this name that I'm going to use for the session, and that's really all there is to the messages that start up a session. Then to begin streaming real-time data, I ask the sensor if it has what data it knows about. The sensor tells me it knows about 17 different kinds of information. I ask it to begin streaming 3 of those to me. It sends me a little JSON document that describes the structure of the data it's going to send, and then it just begins streaming me data as fast as the bandwidth can support it. So there's not a lot of clogging up the telecommunications channel with unwanted information. I've asked it exactly what I want, and it gives me exactly what I want as fast as it can. So that's the protocols that relate to the real-time data. The other protocols, as I said, relate to interacting with a store, including how I find out what information is in a store, asking the store to please give me that data, subscribing to potential changes, and so on. But the focus of this discussion today is about the real-time aspect of ETP. The technology choices for ETP were HTML and WebSocket. WebSocket is the key part of it that sits on top of TCP/IP. It's a normal internet technology that most operators, infrastructure, IT groups would allow to pass, so users can use it more easily without having to ask for a lot of changes in their telecommunications infrastructure. And finally, the ways we distribute ETP. So as I said, there are specification documents for ETP. In addition to the specification documents for ETP, we also have written implementation specifications for the individual versions of our standards. So there's a WITSML 2.0 implementation specification. Our community felt that it was possible that one person who was using WITSML might choose to use ETP differently from another person. So the community decided that we needed to have additional specifications that explain how you use ETP together with any one of our individual standards. So those are freely available on our website like all of our standards. And then the sample code that we have is delivered in an appropriate method for the language. And if you're a developer, you can see that we use NuGet for C#, we're using NPM for JavaScript. Java and C++ are in our source code repository. And the truth is, Energistics people staff haven't written this code. This is all contributed by our members. Some members have included complete sample implementations of ETP servers. Other people have only created some proxy classes. So there's a variety of things that have been contributed by our members, and if you're interested, we'd urge you to get involved and contribute some code into our community as well. And I do finally want to acknowledge the fact that one of our members, PDS, actually has developed a complete developer's kit for ETP, and that's available through our website as well. So there's quite a lot of stuff now, a lot of documentation of the standards, lots of sample code, lots of running code, and a full developer's kit for ETP. So this is a kind of a sea change for Energistics, but our community is really excited about it, and we hope you'll join us and take up the standards and contribute something to our open source community. So that's kind of it for the description of ETP. And with that, I'll give it back to Janet.
Okay, thanks, Jay. And just to let everybody know, we also posted the handout of this presentation in the webinar, so you should be able to download it and follow along that way if you would like. So now I want to turn it over to Thomas and to go through their pilot and their implementation of ETP. So Thomas, you now have control. And now we can hear you as well. Actually, you've self-muted, Thomas. I can't unmute you. Oh, there we go. Thomas?
Thank you, Jana. Yes, my name is Thomas Halland. I work in Statoil's real-time drilling data center. And what I'm going to talk to you about today is how we in Statoil, together with Kongsberg and Baker Hughes, are utilizing ETP to significantly improve our ability to provide remote support from onshore to our drilling operations. First, I'm going to talk about the business cases that we are targeting. Then I'm going to go a bit into details on how Statoil, Kongsberg and Baker Hughes have joined forces to utilize ETP on the existing version of WITSML. Finally, we will elaborate on the next steps and also provide recommendations for how other operators with similar business needs may take advantage of this new technology, which is now available in the market. Statoil have at any moment many active rigs, and a huge number of service companies are at all times involved in performing services at rig site. The actual MWD, LWD services and mud logging are normally performed by one of the major service companies like Baker Hughes, Schlumberger or Halliburton. These companies typically have personnel available at rig site, and they have extended their network from the rig to the onshore support centers. So for these service companies, it's relatively easy to get access to real-time drilling data. But we also have a huge number of other companies, here exemplified by Archer Oil Tools, who have to fly out personnel to rig site in order to perform their contracted work. Let's see if I can bring up the animation here. Here we go. For any operation, there are a long list of different companies involved performing services like completion, cementing jobs, wireline, downhole mechanical isolation, casing running, fluid services, etc. And with the traditional work process, many of these companies have a limited amount of real-time drilling data available in their onshore operation centers, and they need to fly out all their experts to the rig site in order to perform the work. And this is very expensive. They need to wait for the available bed space, book helicopter flight, wait for the operation to be ready, perform the work and occupy bed space again, waiting for the helicopter to fly them back. But with more modern work processes, we reduce the number of people needed at rig site in order to perform all of these jobs. This can be performed by having access to low latency real-time data from the operation in the various contractors' operation centers onshore, combined with cross-trained resources at rig site. Here is an example from a Statoil field. This is a downhole mechanical isolation operation where Archer Oil Tools is performing the work. The rig site operation is supported by the onshore Archer operation centers who are in direct contact with cross-trained resources at rig site from Kosa Deutag. In order to optimize the onshore support and hence minimize the resources needed at rig site, there is identified a need for UHF, CCTV and lower latency drilling data available in the Archer Oil Tools operation centers onshore. The business case as outlined in green for improving this work process is huge. By modernizing, a potential for reducing personnel on board by 2 to 3 persons per job was identified, and only for DMI operations this can save thousands of offshore days for Statoil compared to the traditional work process. There are many things which need to be in place in order for remote support operations to reach its full potential. First, you always have the HSE aspect, which needs to come first. Then you need to have to revise contracts between operators and contractors. You need to inspect capabilities of the companies, their operation centers, the maturity with regards to remote support. You need to look into network, connectivity, hardware, and last but not least, access to real-time drilling data available onshore with very high quality and very low latency. And the last point here is very important, but also very challenging, since the efficiency and quality of the remote support is directly linked to the availability, quality, and low latency on the real-time drilling data available onshore. Not only do they need the full datasets available, but many of these support centers need very low latency to maximize the remote operational support. Some of them have identified a maximum of 1 to 2 seconds total latency, and this includes the network latency. This need is made even more challenging since we experience that the number of channels needed onshore are growing and the sample rate for each channel is increasing. With the available technology in the market today, providing high-frequent, low-latency datasets in a standardized manner have proven challenging and often impossible to achieve, since the current available protocols typically use the query-response mechanism. Every target data store continuously asks for new information, receives a response, then asks for new information, receives a new response, and so on. This is not efficient and it introduces latency. The latency is then further multiplied since there may be many hops and intermediate stores involved before data are stored in the target store used by the remote support team. It is not uncommon that we see total latency up to over 30 seconds, and this creates a remote support challenge, thus increasing the need for personnel on board, which again drives up cost. This is where WithSAML with a new ETP protocol from Energistics comes into play. This protocol establishes a connection all the way from the source server through multiple hops to the target data store, and once the connection is established, data is continuously pushed from source to target. With the ETP protocol, when it was created, the design criteria was to support high-frequency data transfers with low latency. So this seemed a perfect match for the business problem we were trying to solve. Given our high-value business case, Statoil wanted to leverage the power of ETP as soon as possible. Initially, we were under the impression that we needed to wait for a new version of WithSAML, WithSAML 2.0, to be adopted by the industry before we could leverage ETP. But talking to our technology partners in Kongsberg and Baker Hughes, we discovered that the protocol could be implemented on the existing industry-adopted version of WithSAML, which is version 1.4.1.1. And this was later also confirmed by Energistics. So Statoil, Baker Hughes and Kongsberg Digital started to upgrade the technology components needed in 2016. Baker Hughes upgraded their acquisition system at rig site to support sending of real-time drilling data from the rig site. Kongsberg Digital upgraded their Sitecom software so that they would be able to both receive and send data using ETP over WithSAML 1.4.1.1. And in Statoil, we provided live test data from our operations so that we could continuously test and verify the implementations. The first version of the ETP implementation was completed in 2016, and we tested the capabilities streaming data live from a drilling operation in the Troll field in the North Sea. For the initial data transfer, the following subsurface mnemonics were chosen, as these mnemonics have a high update rate during drilling operations. The mnemonics were pulled directly from the acquisition systems in real-time memory, formatted into binary ETP channel data objects, and sent to the target Sitecom WithSAML server in under 10 milliseconds. This meant that the data was made available to the consumer almost immediately after it was available in the acquisition system. And the result lived up to our expectation, and in this small video you will see that there is hardly any latency transferring data from Baker Hughes rig site acquisition system to the Sitecom onshore WithSAML server. The actual latency was close to the network latency, and in this case the network latency is very low from the Troll field since we have fiber optics connectivity to onshore. Based on this promising pilot, Statoil, Kongsberg and Baker Hughes immediately initiated activities for making this technology ready for full production, with the goal of deploying it for all Statoil drilling operations where Baker Hughes are providing the drilling services. We are also now running a series of tests to verify that this technology is future-proof by streaming a large number of channels, and we are also streaming channels containing higher frequency data. The preliminary results from this testing indicate that the ETP protocol seems very scalable, both with regards to extending the number of channels transferred and to increase the sample rate without a significant negative effect on the latency. We hope to be able to release some more detailed numbers on these results in an upcoming SPE paper. We have also demonstrated that the ETP protocol turned out to be relatively firewall friendly, which has earlier been a showstopper for other streaming protocols. We did encounter some challenges in this area, but they turned out to be relatively easy to solve. Another small issue which required handling was network dropouts, since ETP uses an open connection. If the network drops out, the connection has to be re-established, but this was easily overcome using a retry mechanism. The current plan is to have ETP fully deployed for Statoil drilling operations where Baker Hughes are providing drilling services later this year. This technology can help optimize remote operational support for many different work processes and services. Here is an example from one Statoil rig, and as you can see from the extensive set of work processes where low latency real-time drilling data onshore is needed, this shows that at least for us, this is a very high business value in implementing a robust low latency data transfer from rig site to internal and external operation centers. Our work so far indicates that the version of WITSML adopted by the industry today, combined with ETP, seems to solve the problems we have today with too high latency streaming data to all the involved onshore operation centers both inside and outside our company. In Statoil, the combination of ETP and WITSML is recognized as one of the key enablers for providing more efficient remote support to our operations, and thus reduce cost and reduce the number of personnel needed at rig site to perform the various operations. Implementing the standard in Kongsberg and Baker Hughes technology has been less challenging than expected, and the upgraded technology and components are now commercially available for other operators. From Statoil's perspective, we would like to thank Baker Hughes and Kongsberg for joining us and performing this important technology upgrade. Ted Abrahamsen from Kongsberg, Pete Morrison from Baker Hughes, and Kjell Inge Meisal from Statoil are good contact persons if you want to know more about the technical aspects of this technology adoption. We also hope to be able to provide more details in an upcoming SPE paper scheduled to be presented at ADIPEC conference in Abu Dhabi in November this year. There's also an Energistics case study which we hope to release shortly with more details, so stay tuned. Thank you.
Okay, thank you, Thomas. We're going to go into the Q&A period. Before we do that, I thought we'd just do a quick poll question. So now that you know more about ETP and how it's being used by Statoil, Kongsberg, and Baker Hughes, we're interested to know if you're interested in using ETP in your company. So we'll just give you a few seconds to go ahead and answer. And then we will move on to the Q&A. So while you're doing that, just as a reminder, you can record your questions in the Q&A, in the questions area of the control panel. Please do that. Also drawing your attention, if you have questions about this webinar or for Energistics, you're welcome to email us here at info@energistics.org or call us. And of course, you can always go to our website for more information about the standards. So I'm going to go ahead and close the poll and share it. And I guess Thomas and Jay did a great job because 86% are interested in exploring ETP for their company. So well done. All right. So let's turn this over now to the questions that people have. And just bear with me for a moment while I make this a little bit bigger and easier for me to read. Let's see. All right. So as a reminder, you can go to the question box to ask your questions. And I should note, Thomas, that your contention about the Norwegian team has been disputed.
Somebody thinks Viking is better, I think.
Let's see. Yeah, Olivier from Total says, no, sorry, Thomas. Although Norway is good at soccer, they are not the best team in Europe. Vive la France.
Okay, since I'm in Provence, I have to sort of halfway agree to it.
Okay, so, and also to let you know, we have here with us today, and I'm going to unmute them as well, from Kongsberg, we have Ted Abramson and Trond Våge, and from Baker Hughes, we have Peter Geddes. And then on the ETP side from Halliburton, we have Robert Shavy. Thomas and Jay will field the questions, but we'll call on any of these folks to elaborate as necessary. So with that, let me get my questions back here. All right. Okay, so one question came in. Besides Statoil, who else is using ETP? We know other companies are using it, at least in their in test mode. They are not represented here, so I don't know who else is stated publicly.
Right. We know companies are using it, but so far there aren't any companies that we can publicly disclose. But those companies will be able to do that, we hope, in the near future. But as Thomas said, it's a commercially available product from at least Baker Hughes in terms of a service company. And we know lots of other service companies are working on their commercial products, but we're not in a position to be able to announce any of that kind of stuff.
Okay. Okay, so question for Thomas regarding connection loss. Upon reconnection, do you try to catch up with missed data? Is it buffered for a time period, or are there now gaps in the data stream?
I think I'll pass that question over to Peter Geddes from Baker Hughes. Peter, would you elaborate on that?
Yes. The implementation that we made doesn't actually buffer the data. We just treat it as real-time data. The historical data, if you've missed any data, would still come through in WITSML logs at the moment. But there's nothing stopping you buffering the data as well.
Right. The ETP specification caters to this. So when you create a connection, ETP recognizes that there could be two styles of sensing devices or senders. You could have an intelligent sensor that actually has a buffering capability so that when you reconnect, you can choose to catch up all the data that you missed. You may only want to see the last 10 seconds of data that you missed. But then there's a kind of a simple streamer that we recognize that there may be sensors in the field that don't have that sort of compute capability. So the standard caters for these, and it's up to a commercial implementer which of those features they choose to implement, and it sounds like Baker has opted to just implement simple streamers.
Okay. All right, so next question. During testing from Statoil, Baker Hughes, Kongsberg, was this test done solely in the office or from offshore to onshore data center? Do they envision this from onshore data center to onshore data center or directly from the rig site aggregation system?
I can
Thomas,
try.
Came from Troll. Didn't you say the data was coming from Troll during the test? Came from offshore, Troll A?
Yes. For the pilot, the data set was live drilling data from the Troll A field, and it came from a Baker Hughes acquisition system at rig site, and it streamed into our Sitecom onshore server in Statoil. What we also see is that in Statoil we have a lot of service companies who are doing various types of jobs, and we have two options there. We can either give them access directly to our WithSAML server technology from Kongsberg, or if they have ETP or WithSAML data streaming capabilities, we can have an ETP connection directly into their onshore support centers. Both of those options. So it depends a little bit. Some of these service companies may fairly shortly develop ETP capabilities, but others we will probably give them access to our technology from Kongsberg so that they can get access to low latency real-time drilling data in their operation centers.
Okay, thanks, Thomas. Okay, another question. Does Statoil plan to use ETP to support even WithSAML data transfers with the use of the ETP standard for transfers from rig to town purposes only as a hybrid solution while we await others to upgrade their rig site systems?
The plan for us is to upgrade it for real-time drilling data transfers. We will probably in an interim period have a hybrid solution where we have both the old WithSAML with SOAP running in parallel, but we hope to fairly quickly have this as the only primary data streaming protocol, since it has superior transfer speeds and lower latency.
Okay. Another question, and I'm really not sure about if you can answer all of this, but what is the estimated cost of the implementation of ETP? They're thinking about equipment upgrades, programming changes, that sort of thing.
Yeah, I'm not sure. I don't have an overview of that, but I can say that that at least from our perspective, this has been a very fluent technology adoption so far. We haven't experienced any major problems which has required a lot of time and effort from our side.
Yeah, I think maybe Ted would want to comment, but as far as I know, it was, from a software perspective, it was just an upgrade to Sitecom 10.1. It was a normal upgrade, software upgrade. Right, Ted?
Yes, that's right. So we did it between 10 and 10.1. And it was, I would say, I mean, Sitecom is a quite extensive product. And we also took the opportunity to use ETP for all our internal real-time cache replications, where we previously had some proprietary binary interfaces. So now we use ETP for kind of all internal data flows real-time wise, and that has really proven ETP capabilities. But at the same time, of course, also increased the project on our side. So it took a year, I would say, to kind of do the full development cycle on ETP. But of course, if the scope had been much less, I mean, if it's a pure client application, like we did we have a product called Discovery Viewer, which is a new visualization package. There it was a matter of weeks before we had the ETP stack necessary to do the display of real-time values. So it depends very much of upon the scope, of course. Our experience with ETP from a development perspective is very good.
Okay, thanks, Ted. Okay, we'll go on to the next question, which is what sort of maximum data rates have been achieved?
In our prototyping, we, at one of our integration lab meetings, we were moving, I think somebody from Chevron, Phil McKenzie from Chevron, had an implementation of ETP on an Arduino, which is a little computer like a Raspberry Pi, and he was moving 300,000 data points a second. But in real life, there's a fiber connection to Troll from shore, as far as I remember, from Norwegian infrastructure. So, Thomas, did you all actually measure a maximum data rate through that fiber infrastructure?
I think we did, but I don't have the numbers here. Ted or Peter, are you able to comment or provide some numbers?
Well, Ted here. On the actual pilot we did, it was, as you shown, Thomas, it was only a tenfold of tags, or channels. So it didn't really give a bandwidth problem. Latency was the main study here. In our lab, when we have tested Sitecom 10.1 for performance or load, we have had up to 7 parallel or replicated Sitecom servers with a data rate of 10,000 channels and data rate of 1 hertz. That has gone at a quite low, below 10% CPU load on all machines, and within good memory and bandwidth capacity. So having the full kind of enterprise load seems to be very doable in our configurations.
Great, thanks, Ted. Okay, next question is, was schema completely changed from WITSML 141 to ETP?
So I'll answer that. So in the world of WITSML with ETP, there's 2 aspects to it. You have, as I was saying in ETP, there's the real-time streaming aspect, and then there's the aspect of the store. So using either WITSML 1.4 or the new WITSML 2.0 over ETP, you're moving normal WITSML objects when you interact with the store. So if you get a well object or a wellbore object or a trajectory object, those normal objects come the same as they always have. It's just that ETP gives an improved API over the old SOAP. But those parts of WITSML, which WITSML 1.4, which related to real-time streaming, are pretty much completely replaced by the streaming part. And this is why we need to have an implementation specification. WITSML 2.0, the new WITSML, is completely designed to work with ETP, so there's no strangeness. But you have to decide how to retrofit the ETP concepts onto the old WITSML 1.4. So that's why there'll be a special guide published, or a specification published, for how to do that. But in general, the only bits of WITSML 1.4 that were replaced were the parts that relate to real time. So that would be the change log, the message object, the log object. Those are pretty much replaced. But as I said, in WITSML 2, in addition to getting the new functionality around data assurance and activity tracking and all the new fancy features in WITSML 2, it's also specifically designed to work with ETP. So, and that'll be coming commercially, from the same vendors that we're discussing today as well.
Okay, another question is, I have noticed high frequency, low latency capability. Is this due to the use of WSS? Same with the Firewall Friendly. Is this due to the use of same port that we use for HTTP, HTTPS?
Yes and yes.
Okay.
Yeah, that was the whole point. One of the design criteria was, one of the problems with WITS level 0 was that people couldn't forward all the ports and reconfigure all their entire IT infrastructure just to allow this real-time data through. But since we've used WebSocket, then you can use normal port 80 and port 443, which are for non-IT people, those are the little holes in your company's firewall that let the internet through. And of course, we suspect that people will use the secure one, which is port 443. So yeah, all of that's incorporated into the design of ETP.
Okay. Okay, so still a lot of service and drilling companies provide data in WITS format or WITSML 1311. As you mentioned, ETP will work only with WITSML 1411. Is that a limitation, and how do you plan to tackle that?
I can answer from Statoil's point of view, and for our operation, we require WITSML for all our operations, at least all our offshore operations. There may be some onshore operations where we don't have that requirement. But since we are already a fully WITSML enabled company, this is not a problem for us.
In general, as far as WITS goes, there has been a comment made comments have been made previously that people were unsure how WITSML mapped onto WITS, and then that WITS could do certain things that WITSML can't. In fact, with WITSML 2, that argument completely goes away, and WITSML 2 can specifically do everything WITS level 0 can do on an improved infrastructure, et cetera, et cetera. So we were going to, in fact, try to present a paper explaining exactly how to replace WITS with WITSML, but I don't think that paper was accepted.
No, but we do still hope to do the paper and make it available on our website, if nothing else.
Right. So there'll be a resource that you can go to if you want to replace WITS level 0. As far as WITSML 131, the industry, the larger operators have begun requiring WITSML 141 rather than 131, and even though WITSML 141 has been out for 6 years, the take-up was a little bit slow, but now the service companies are beginning to support WITSML 1.4, and some companies may choose to skip WITSML 1.4 and go directly from 1.3 to WITSML 2, but our preference is for people to go to the version of WITSML that's designed to work with ETP. But as Thomas said, they wanted the business benefit from ETP before WITSML 2 was even out. So, and that's perfectly okay as well. So I guess 131 will slowly go away as it gets replaced either by WITSML 1.4 or WITSML 2.0.
Okay. Are you able to provide more details about the firewall issues you had to work around and any other network configurations or issues you came across?
We'll have to leave that to either Kongsberg or Baker to comment on.
I suggest Trond here from Kongsberg takes the reply here.
Yeah, it was related to proxy settings, and we had to set a static proxy inside when creating the connection. So that was it. This was a quick fix from our side, but nothing that we had in the beginning. So that's why it's really important to test in the field to see that it's working through the normal environment at the customer side.
Okay, and we really have time for probably one more question, so I'm trying to find a good one here for you. In terms of data frequency rates and numbers of channels, how much improvement did you see using the new ETP protocol compared with the traditional WITSML transfer method?
I don't have any exact numbers from Statoil's point of view, but I can comment on what our users are saying, and they're basically saying that it is a significant improvements. Some of them even use the word a step change compared to what they're used to. But I don't have any exact numbers. I don't know, Peter or Ted, do you have any more scientific numbers than my sort of happy user perspective?
Ted here, I can comment on it. It depends a bit on the load pattern, because I mean the SOAP strategy in WITSML can be very efficient, but also quite effective. depending on kind of the pattern of the communication. But in the tests we did on the pilot here, I think we can say that we had a tenfold improvement in the response time or latency reduction, and a 10 times reduction in bandwidth requirements. That is a rough number. It's based on the specific tests we did. It's not a scientific result. It's more kind of given the load we have, given the tests we did, that is the numbers we have.
Okay. Well, thank you, Jay and Thomas, and also Trond, Ted, Peter, and Robert for joining us. We have reached our time limit, so we're going to stop for today. I should note that the recording didn't start until a little bit after Jay started talking, but we went ahead and recorded the whole webinar beyond that point, so we will be posting it. Apologies in advance for the first section, but the main meat of the webinar was recorded, so we will get that posted for people. Just as a reminder, the handout is available. If you haven't already downloaded it, you can do that. And if you didn't get a chance before the webinar stops altogether, just send me a note at info@energistics.org. So with that, I'd like to thank you all for attending, and we will hope you will join a future webinar. Thank you.